Hi, I'm Tyler Farah, and in this video we're going to up the difficulty by drawing Newman projections now for 3-carbon alkanes. First and foremost, I want you to think about what's so special about a 3-carbon alkane. In the video on Newman projections of 2-carbon alkanes, we learned that Newman projections are a way of looking down a carbon-carbon single bond. And so for a 2-carbon alkane, we can see the front carbon, and the back carbon we saw gets obscured or hidden behind that front carbon. So for a 2-carbon alkane, that's it. We can see one carbon and we know that the other one is safely tucked behind the carbon that we can see. Those are all the carbons in the molecule. Well, now for a 3-carbon alkane, we're going to have a third carbon that we have to deal with. And in this lesson, we're going to learn a method for dealing with that third carbon. But the reason why this is an important skill is that if we can draw a Newman projection for a 3-carbon alkane, the same trick is going to get used for 4-carbon alkanes or 5-carbon alkanes or 55-carbon alkanes. And the trick actually isn't that challenging. We're going to draw the 2 carbons that we're looking down as normal, and then we're going to take the third carbon or any remaining carbons and anything else that's attached to that extra group, and we're just going to condense it down into the molecular formula for that group. But let's see an example to prove it. Here, we're asked to draw all 4 Newman projections for this molecule. And so I want to start out by thinking about why there are going to be 4 different Newman projections for this molecule. You might remember from the 2-carbon alkane video that we're going to imagine ourselves as a little person floating next to this bond, and here we are looking down this carbon-carbon bond. Of course, we can look at that same bond from the back side. And now, in our 3-carbon alkane, we could also come and float next to this bond and look down that carbon-carbon bond, or come around to the back side of that bond as well. So we're going to end up seeing that there are 4 different Newman projections possible for this molecule. They're all going to be very similar because they're all just different ways of looking at the same molecule. We'll go ahead and begin, and one more quick review from the 2-carbon alkane video. Remember, if you were looking at this bond, there's your left hand, here's your right hand, and what we learned in the last video is that when you're on the left of a bond, things that point into the page are going to end up being on the left of the molecule. So we would predict that if we were going to draw the first Newman projection for this first carbon-carbon bond, that we would have a circle representing the carbon that we're looking at. We'd have 3 spokes coming off the front of that circle for the 3 substituents that are attached. We'd have 3 more spokes coming off the back that are presumed to be attached to the carbon that we can't see. And furthermore, we would predict that on the front carbon, the hydrogen atom would be on the left since it's pointing into the page. And on the back carbon, the bromine atom would be on the left since, again, it's pointing into the page. What we would find is that below us, there is a hydroxyl group, and that leaves the other 2 groups, NH2 and the hydrogen on the right. So what we have to do now is to figure out how to deal with this whole functional group back here, this carbon and everything else that's attached to it. Well, I want to bring up a 3D model, and this is going to serve 2 purposes. First, it'll confirm that our Newman projection so far is correct, and second, it'll give us a little bit of perspective about what that extra carbon would look like if we were actually floating next to this molecule. So what we're going to do is we're going to rotate this so that the bond we're looking down is horizontal, and then we're going to spin it around so that we can see the actual view that we would see if we were floating in space in front of that carbon. And you can see that our predictions so far have been entirely accurate. Bromine on the left, NH2 on the right. So how do we handle that extra carbon? Well, again, the trick is pretty straightforward. We just write the carbon and anything attached to it in its molecular formula. And there we have it. If we were to come around to the other side of this same bond, we would predict that our Newman structure would look very, very similar. Again, carbon that we are looking at, 2 substituents pointing down, 1 substituent pointing up, 3 more substituents on the back. And this time we can either think about the fact that we've come around 180 degrees, so everything is going to be swapped from left to right. We're basically looking at the mirror image. Or we can use the trick that when you are up here on the right of a bond, things pointing into the screen are going to be on the right. So in this case, we would expect the bromine to be on the right and the hydrogen on the carbon furthest from us to be on the right. And of course, the substituents at the top and bottom don't change. It's just that now our CH3 group is attached to the carbon that's closest to us. So great, we're halfway there and we're picking up speed already, right? We're getting pretty good at this by now. So let's take a look now. Imagine that you were to come fly right up here. So now we're looking down the other carbon-carbon bond, and we'll just start at the left and work our way to the right again. We can set up the Newman projection as normal. We are not expecting any surprises here, and coming down in this direction, we've got bromine. Again, we're on the left, so things that go into the page point to the left. Hydrogen, we'll deal with all this in just a second, but notice on that back carbon, the three substituents are really easy now on the carbon that's behind us, at the back of this molecule, that is. We just have 3 hydrogens. So now what we have to do is figure out how to deal with all of this functional group up here. And I saved this for last because it's a little bit more challenging this time. There's certainly a lot more attached to that extra carbon. But again, the trick is the same. Just write out the functional groups, the condensed molecular formula for this whole thing, and there we are. That's our Newman projection. Of course, the final Newman projection for this molecule is going to be basically the mirror image of that. So we are now looking at directly at the carbon that has all those hydrogens bound. We know that if we're thinking mirror images, now bromine's going to be on the right. That puts a hydrogen over here. And again, the functional group up top has not changed. Just now, it's even further away from us. And you can see that because now it's bound to the back carbon, the carbon that's on the opposite side of the molecule. So that's that. That's the whole method for drawing 3-carbon alkanes as Newman projections. And if we had 4 or 5 carbons, we would do the same thing. We would just stick all those extra carbons on one of the spokes and condense down the carbons and anything else attached into their simple molecular formula. Thanks for watching.